We're now going to go over the integration by parts formula that you'll need to know and the steps that you can follow when solving an integral using this method. The integration by parts formula looks like this. You're going to use it when you're integrating two functions and you set one equal to u right here, and then the other one you're going to set equal to dv. And sometimes that other function might just be dx. The formula is uv minus the integral of v du. I want to show you real quick where this formula comes from so it doesn't feel like I'm just pulling it out of a hat. It actually comes from the product rule. We let u be the function f of x, and we're going to let v be the function g of x. We then use the product rule, that's right here, the derivative with respect to x of f times g, and we get that expression on the right. Then what we're going to do is we're going to integrate both sides of the equation. We have the integral of a derivative, so we get back f of x times g of x and this formula on the right-hand side. Now all we need to do is put this back in terms of u and v. F is u, g is v, and that gives us this formula on the right-hand side. Now we just have to solve for the integral of u dv, and out pops our integration by parts formula. You can compare that back up here to the top and see that that's exactly our formula. Now that we know the formula that we need to use, let's go over the 3 steps that you can follow when integrating using integration by parts. Step 1 is by far the hardest, and in step 1, we are going to choose u to be the function that can be differentiated repeatedly until it becomes 0. An example of this would be the x in this integral x e to the x dx, or we can choose u to be the function that becomes simpler when differentiated. An example of this would be if we're trying to integrate natural log x, and we'll set natural log x equal to u, and then just remember that the derivative of that is 1 over x, so it becomes algebraic, and that's considered simpler. Let's also note that dv is the part that remains. So in our first example, dv would be e to the x dx, and in our second example, dv is just dx. Looking over here on the right-hand side, the acronym ILATE is just a shortcut for this same idea for choosing u. The functions here that you can choose to be equal to u, either inverse, logarithmic, algebraic, trigonometric, or exponential, are listed roughly in the order that they simplify when differentiated. The exception to this is that when both factors are equally low in the list, such as a trigonometric like cosine x and an exponential like e to the x, this shortcut doesn't help and we have to do something different. I'll show you what to do for a problem like that when we go through our examples. Let's now look at steps 2 and 3. They are much easier. Step 2 is to just set up and fill in the following table. You choose u and then take its derivative, and then the part that isn't u is your dv, and you integrate that part. And then in step 3, you just apply the formula. The integral of u dv is equal to uv minus the integral of v du. When I implement this formula, I usually use arrows. Let me show you what that looks like. You multiply u times v, so I make an arrow that looks like this, and then you subtract v du, so to indicate the subtraction, I put an arrow that goes like that to the left. And that just helps me remember the formula. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.